Hello guys, and welcome to today's webinar with Jeremiah Peschka, Failure to Launch, Code, Upload and Explode. Before we hand over to Jeremiah, I just want to do a very quick introduction to Redgate and what we do here in the .NET division at Redgate. So to keep it short, we have a few products that help .NET developers. The first one is Ants Performance Profiler, which is a .NET code profiler used for identifying bottlenecks in code. We've recently launched the latest version, which is 7.3, which contains lots of cool stuff. I won't go into the details now, but you can check that out on the Redgate site. Then we have Ants Memory Profiler, used for finding leaks in .NET applications and optimizing .NET code. Also Smart Assembly, which is a .NET obfuscator, which also has some error reporting functionality. And finally, .NET Reflector, which is used to browse, analyze, and debug .NET code. So that's all I'm going to say for now about Redgate. I know you're all keen to hear what Jeremiah has to say, so there's a link at the bottom of the screen if you want to find out more information, or just get in touch with us at the end. So the Redgaters we have here today are myself, Michaela Murray, aka Miss.net. You can contact me on Twitter at Miss.net. And I'm a product marketing specialist within the .NET division at Redgate, and I'm currently working on Ants Performance Profiler. Then we have Elizabeth Ayer. Elizabeth is one of our product managers, also working on Ants Performance Profiler, and Elizabeth will be on hand today to answer any questions you may have. Okay, so over to Jeremiah. Bear with us a few moments while we just change presenters.
Thank you very much.
Thanks, Jeremiah.
All right, everyone should be seeing a PowerPoint screen now, and I'm going to go ahead and jump right in. Welcome to Code, Upload, Explode. I am Jeremiah Peschka. I am a Microsoft SQL Server MVP. That doesn't mean that I don't like the cloud. I don't like .NET. I love both of them. I started a company called Brent Ozar PLF. We solve database problems as well as cloud scalability issues. I have a number of certifications in SQL Server, and in my free time, I maintain a library called Corrugated Iron. It's a .NET client for a NoSQL database called Riak. If you have questions, you can hit me up at jeremiah@brentozar.com. You can also find me on Twitter as PeschkaJ. So I'm going to just jump right in after that. A long time ago, I wrote a lot of .NET code, and I thought that I was doing a pretty good job of writing code and testing my code by writing unit tests and then going live with a fast, stable production server. And I really thought that it looked a lot like this. I thought it was a lot like putting a space shuttle into orbit. We had something beautiful. It was a well-tuned endeavor. What I actually did was I wrote code and I tested my functionality, but I never really tested performance. I knew that the application would work as it was supposed to work. I had unit tests, but I really didn't know how fast they were, apart from how much time my unit tests took. I didn't know how my application would perform with any type of load on it. We would guess at server requirements when we put an application out. We'd look at the current server and say, well, it needs to be about 50% faster than what we've got right now. And then when performance problems would inevitably crop up in production, we'd scramble to track them down and fix them using a lot of things like console.writeLine or attaching traces and step through debuggers and doing a lot of very, very primitive things to try to make the code run faster. And my beautiful space shuttle actually ended up looking like this. Not really a great way to get into outer space. Some famous failures to launch and to scale. One most recently is the SQL Server 2012 launch event. If you don't really follow SQL Server very much, this was a huge debacle. When the online virtual launch happened, most people couldn't even log into the site because the virtual hosting provider hadn't provisioned enough physical hardware to manage the demand for people who were trying to attend this launch. There was a lot of flack that Microsoft took from this vendor's actions, and eventually they got it resolved, but it took a lot of time and there was a lot of short-lived bad publicity around it. Anyone who's used Twitter is very familiar with the fail whale, and they know that, especially in the early days of Twitter, things would just stop working for minutes or even hours. And big events will occasionally take Twitter offline as well. If Justin Bieber shows up at a Starbucks, Twitter may very well fall down. Anytime you see private beta on a website, that usually means they haven't figured out how to scale their application effectively yet. So they're only adding more people in as they know that they're able to keep buying more hardware. And online sales can really take down a business too. A major sports team that was one of our clients, they were on their way to a national championship, and they started running into scalability problems. Every time that their marketing team would post a sale to Facebook or Twitter, the online storefront would actually crash under the load of users coming in who wanted to buy memorabilia. They wanted to buy jerseys or posters to celebrate their favorite team. And this caused a lot of problems for them because they were losing revenue every time they tried to post a sale. There are a lot of reasons for failure. One of the biggest ones is the traditional purchasing and procurement cycle. This varies from company to company, but frequently what you'll see is you'll either purchase your servers at the end of the month or the end of the quarter, so you'll line up with your vendors' end of quarter deals. You'll have to wait 4 to 6 weeks for that server to show up, and then you'll have to wait 2 to 4 weeks for your technicians to provision the server, get it racked, get the operating system installed, install all your basic monitoring on it. This takes a long time. If you're stuck ordering at the end of the quarter, it may be 5 months before your server is actually available for you. This obviously doesn't let us respond flexibly to customer demand. You can also run into what's called a single site problem. This is just where you put all of your eggs in one basket. You have one physical site where all of your hardware and your software is hosted. And if that site goes down, if anything happens, if lightning strikes a transformer, if a impaired driver runs into the power couplings that link your building to the national power grid, you can have your entire site taken down for hours or even days. Budget can be a big limiting factor too. With that traditional purchasing and procurement cycle, teams tend to over-provision servers. They buy a much bigger server than they need because they know they're going to have to throw more hardware on it, and they're going to have to wait a long time to get another server to replace an existing one. As a result, people tend to overspend. Or there's just a lack of knowledge. If you haven't encountered these problems before, the problems you encounter when you move up to a more highly flexible, scalable environment, if you haven't run into this, this is going to be a very daunting thing to deal with. There's not a lot of knowledge documented that's well documented yet. This is still very much a tribal knowledge area. So we need a more scientific approach to this problem. You know, much like I thought I was doing something very scientific at the beginning, and I really was just cobbling together solutions and pushing them up into production in the hopes that it was going to work well, I needed a more scientific approach. I've developed that over the course of my career, and also you guys need a more scientific approach too. You need to make this a repeatable process. So we're going to talk about some ways that you can go ahead and do that right now. The big thing is you need to know where you're measuring. Your laptop is not the same thing as your data center. On your laptop, everything lives on one system. Your database is on the same server, I use that term loosely, as your application and as your web server if you have a 3 or multi-tiered application. So there's no network overhead between that. You don't have to deal with as much physical problems, and you don't have to deal with concurrency. In a production environment, you have switches and routers and a lot of other physical equipment in place. And in a virtual environment, your servers may be separated by up to 1 or 2 miles of Ethernet cable. So you need to make sure that you're measuring things appropriately for your environment. You can't trust the performance on your laptop to be the same thing that you see in production. You should always keep that in mind when you are taking a look at your code, when you're profiling and testing for performance. You also really want to know what you're measuring. There are 4 main areas that we look at for bottlenecks. There's memory pressure. How much RAM are you using? Are you using large objects when you could potentially be using something much more compact? What does your CPU utilization look like? Have you chosen an inefficient algorithm? Do you really know if your algorithm is inefficient, or perhaps there are some other techniques you can be using to make your code run faster? You obviously want to measure your memory consumption as well as your CPU utilization. These are both very finite resources. and we have a lot of control over what happens, so we can use less memory and use less CPU. You also want to measure latencies. How long does it take you to communicate between the different tiers of your application? Network latency is something that usually we don't have a lot of control over, so you want to develop your application in a way that you are aware of the latency of your network, and you take that into account to how your application communicates between tiers. If you have a slower network, you may want to push things off and use caching and queues to make activities asynchronous, to hide that latency from your users. And likewise, storage can be a tremendous problem for many applications. Disks can only spin so fast, and usually they're attached to an enterprise server via a SAN, and frequently that storage area network is attached over Ethernet cables. It might be 10 gigabit Ethernet, but it's still attached over some cable. It goes through some routing network, and there can be latency talking to the storage as well. Now, the traditional way to measure these various factors is using operational tools like perfmon or various commercial products from companies like Ipswitch. These are great tools, but they tell us what has occurred in the past, and they're not very granular for developers. They let us see what's going on the server as a whole. I know that CPU is at 80%, but I don't know if it's my ASP.NET application, another team's application, or if a full virus scan is running on the server. I just know that CPU is at 80%. We only know that there's a problem. We don't know where it is, and we can't really do much about it with that information. Amazon Web Services have their own monitoring system as well. It's very similar to perfmon. It's called CloudWatch. It collects metrics at about a 1-minute interval. You can derive a lot of very fantastic information out of it and use tools like Amazon CloudFormation and CloudWatch together to help you dynamically scale, but these are still operational tools. This is to react to a problem, not to predict potential problems and find ways to reduce that load and reduce the likelihood of, say, runaway CPU coming out. What we want to do instead is, during our development process, find ways to test our application, find the limits of our application, and then tune that back. We'll tune our CPU, we'll reduce memory utilization, and figure out how we're going to respond to it. Operational tools don't get us there. So we need something finer grained. There are a lot of different fine-grained tools available. The most obvious thing that comes into my head first was using some kind of instrumentation. You attach different monitors to your software. Unfortunately, you have to write the hooks to attach that instrumentation to. So it's a lot of extra work that you need to put in place before you can even use any kind of instrumentation with your code. And ultimately, instrumentation is used more operationally than it is in development. This is something you use when you need to measure, say, transactions that your application considers to be transactions. Maybe it's credit card transactions per second, or banking transactions per second, or number of emails sent per second. You'll have your own internal metrics, and you'll want to write instrumentation tools to detect those. They can help you, but this is more of a tool for custom operational monitoring. You could also use a debugger, but the problem is debuggers add overhead, and they attach to one thread. They don't really let us check a lot of what's going on outside of that single thread of execution, and they really only make sense when you're trying to track down a bug. It's a step-through process. It isn't going to let you find out where CPU problems are. It's going to let you find out where a logic problem is. Tracing is very similar to a combination of instrumentation and debugging. It's the best and worst of both worlds. You can get a lot of very good information out of it, but it's a lot of work to get this set up, and it adds a lot of overhead, so it really isn't going to help you get there. Profilers, however, give us insight to what's running as a whole. They add some of the overhead of debuggers. Nothing you do is free, especially when CPU is involved. But you can get considerable insight into what's actually going on in your server, just like instrumentation and tracing. And the upside is you can attach and deattach as needed. So there are two ways to profile. I'm only going to demo this first one, which is profiling by hand. This can be time-consuming. You have to click and start a profiler and set up the profiler session. The timings can change, so you may be typing things in differently. There may be a slight delay in how activity occurs. That's okay. We're really just trying to get a general idea at this point. And also, you and I, people, human beings, we're not as prone to mistakes or creativity as you think, and it can be very difficult to compare results across multiple profiler runs because of that variability in our behavior as humans. Now, there's another way you can do this. You can automate these tools. The nice thing about automation is it's repeatable. When you run a workload and profile that workload, the only thing you're changing is the code that's running in the back end. So you can say, you can actually compare two runs against each other. You know exactly what is going to happen, the order things are going to happen, and so you just monitor the effects of that. This can have some complex setup, especially for a desktop app, but this can be really worth it if you want a reliable automated performance test. So now we're going to flip over and take a look at a demo. So everyone should be able to see my Visual Studio now, and it is starting up the project. I apologize for this. It appears to have crashed earlier today. While this is running, you'll see I have this, hold on, it's still loading up. You see this ants menu item here. And from this, you can actually go ahead and launch the profilers, which you'll see once this solution is loaded up. And I'm using the Nerd Dinner solution. You can download it from Codeplex. It's meant to help nerds organize dinners at conferences so you can all just meet and informally chat. I took the application and I did my best to make it terrible. Seeing as how I don't write .NET code for a full-time job, that was pretty easy to do. I've left the original code in. Redgate have thoughtfully made my terrible contributions to the software world available for you to review and make fun of later. So you can download that after the presentation. So what we're going to do is go in here, click on Ants, and say Launch the Performance Profiler. This is actually going to bring up a menu where I can quickly set up my Performance Profiler and then run it. So otherwise you can actually just say profile the application once you have a setup that you know is good. This works by reading perfmon counters, but we're looking at one specific process with only one person using it, so it becomes very easy to track down and take a look at what's going on, and you'll see a lot of details in here as Ants spins up. So it says create a new profiling session to start a new project. Takes a minute because it's a virtual machine on a Mac. You guys can all make fun of me quietly in the background for that. So here we go, and we already know that we're looking at an ASP.NET web application. You have a lot of different options in here, including even SharePoint web apps. And here are our charting options. These are different performance counters to record. If you add a lot of counters, it's going to add a lot of overhead, but you may need to look at different things. You can get a description of each counter. I actually just go ahead and stick with these defaults for now. And I'm going to say Start Profiling. This is going to fire up the profiler, and then it's going to attach the profiler to a running process. In this case, we're starting up a .NET process to run a web server. So it takes a second as it spins up that process. And this does take a little bit of time the first time you do it, but it gets quicker, and you'll just use this. It's the same thing as telling your boss you're currently compiling code. So right away you can see that something is happening on my server. There's some activity, and this thick red line that we're tracking processor time, how much CPU is being used. In the background, you can actually see the Nerd Dinner application has come up and loaded. And I've loaded my database with a large quantity of sample data. So looking back at this, I'll say, well, I'd like to know what happens in this window. So I'll select it, mark it, and I'm going to say bookmark region, so that way I can come back to this later. Continuing on, I'm going to go and I'm going to say I want to find one, and let's see if we can find it near 54355 as a zip code. So this is going to go off, and we're doing a search in our database. And you can see again in the background that there is an incredible amount of CPU being used. We're hovering right around 100% CPU utilization. When we switch back over, we're still searching. Something is happening in the background that's taking up a lot of time. So this is definitely something that I want to look into after the fact. You can also change what this is looking at, and you can review and say, I want to look at my working set of memory. That's this thick orange line now, and you can see that something is gradually eating all of the memory on this system. We don't know what it is yet, but this is definitely something that we want to look into and figure out, okay, what terrible piece of code has been introduced that is causing all of this memory to be used? odds are there's some sort of garbage collection storm going on in the background. Something awful is happening that is causing major performance problems. So I'm also going to bookmark this and say that I want to look at it later, and then flip back over to the application and just dive into one of these individual dinners itself. We'll pick this one. So again, we're going to load up this specific dinner. We can see it happening again in the background here. It's a very slight blip. And the dinner is still loading, so I know that I want to take a look at this because this is happening much slower than I think it should be. So again, I'm going to bookmark this region and then head back over and stop profiling the application. So now I have several areas that I know I want to look at. I know there's some kind of problem in each of these areas, and so I'm going to go in and take a look. And when I look at this first section, I can see my different HTTP requests. I can see the significant areas of code that I went through, and also how much percent of the time was spent inside that method, that activity, and all of its child items. So as I start digging through this, I can see that about 41% of my time is spent in find upcoming dinners. And then this select, the SQL statement was run almost 1,000 times, which is far more often than I would think something would be run. I can click on this database call and bring up a separate menu that's actually going to go ahead and show me exactly what's going on. So we're going and we're pulling back a bunch of RSVPs for these different events, and it appears to be doing 1,000 of these to get all these individual ones, and it's taking almost an entire second to pull back this data. So obviously I know that there's something wrong in my application's code where this database call is occurring. Hopping back out to the performance tab up here, we can flip back, click on the find upcoming dinners, and actually see which individual lines of code are involved and start making plans and say, okay, well, I know I need to go ahead and look in this, and I see some fool has written a for each loop where they're looping through the dinners one at a time as opposed to pulling this information back with one single join. I can also see, looking up here in the graph of the profiling, exactly when this selected item was run in my application. It'll be highlighted in green, so if something is run multiple times, it'll actually show throughout the application. Again, I can flip over and take a look at another request and again see this item right here is run 1.9 million times. So I know that this is something that I really want to go into and take a look at. On its own, it's not a particularly problematic item, but it's being executed 1.9 million times, so odds are there's something in here that really needs to be improved. And again, I can go through and I can find areas where different methods are being called. My search controller is called here. So I can go through and I can identify problem areas, and I can also see where something is repeatedly called through my code. And finally, what I can do is I can change the way I'm looking at this and say look at either a grid of my methods, or I can stop learning how to use a mouse. I can look at an entire call graph of the activity that's going on. And I can go through and you can navigate that and build up a beautiful picture of how your code is actually constructed, where everything is going, and it's laid out in a way that visually is fairly easy for most people to understand. Again, we can look in here and we can dive into individual methods and see exactly what's going on. And these little red bars up here actually let us know when an exception occurs, so we can go, we can dig into the code itself at certain areas and say, okay, if there are problems here, let's go figure out what those actual problems are, dive into it, and then try to figure out what the exception is, why it's happening, and we'll know whether or not it's being bubbled up to the user or if it's staying hidden down in our application code. So you can use profiling to help you tune your code, but after the launch, you also need some other things. You can use the profiling information to help you out. You want to think about layers. We know that there's a browser, there's a network, there's a web server, there's some network, there's an application server and some network, and a database server, and a little bit of network, and then storage. And if anything fails at any point, something awful is going to happen, and that delicious cake of an application that we have is going to collapse. When one layer falls apart, everything else is going to fall apart as well. Where does profiling come into play? We can isolate and measure individual services. We can start understanding how individual services will perform both successfully and in failure conditions. Then we can develop repeatable performance tests. We can do what we can to make things faster. We can also test how our application behaves in the event that something exceptional occurs, like our database disappears, and make sure that our application responds quickly and efficiently, even if that is just to show the user an oops, there's a problem error page. We can also, as we're separating out our services, we can tune each service in isolation. You can connect to individual services and tune them separately from each other instead of trying to tune your application as a whole, and you can make these services robust in isolation. We were looking at perf mod counters while we're profiling, and you can use those same metrics to help you guide how things operate in production. Netflix's mantra is to build for fail, not scale. They focus on things at the service level. They say if this service goes above a certain point, there's a problem. Take care of it. They don't look at individual servers. They look at their services as an aggregate. One of the fantastic things that Amazon's CloudWatch monitoring tools allow you to do is they allow you to look at your servers by service tags. So you can look at just web services. You can look at just the web server. And when you want to deal with failure, you can monitor at certain levels, but you want to find your critical path. What is the most critical thing that's going to happen to keep that server online? And recognize that failure does not have to be catastrophic. It can mean just mean a degradation of functionality, or it can mean that you display certain messages to users, or you operate from caching and queuing mechanisms and operate asynchronously until you can bring your storage systems or your lower systems online again. If functionality is critical, you can move it into services and put that into scalability tiers. Amazon provides you a lot of functionality, and other cloud services provide you a lot of functionality to automatically scale your application up and down and dynamically respond to failures. Managed services are another great way to deal with these issues. AWS has something called CloudWatch, which is their managed monitoring service. You can combine that with their auto-scaling functionality and a tool called CloudFormation to allow you to dynamically respond up and down as scale events happen. As CPU utilization increases or memory utilization increases or network utilization increases, you can respond to that appropriately. You can monitor your performance both within the application as you develop it, as you're profiling. You can grab those performance monitor counters, and you can use that to develop your production monitoring as well and give those tools to your operational team. This will also let you respond to changes well because you'll know what warning conditions look like long before they actually become problems. You can use the knowledge of tuning your application to make your application run smoothly in production. Some 5 keys for successful cloud and Amazon Web Services deployments specifically are to have an accurate set of metrics for your product. You're building this up yourself as you're profiling your application. You know what it looks like. You know how to make it fast as you communicate that information to your operational team. They can make your application generate warnings as it becomes slower or as it nears these failure points. You want to measure everywhere that you can. Measure in development, record those numbers, and use them to verify that you're seeing something similar in test, that you're seeing something similar in production, or you can adjust appropriately. You may know that your production machine is 4 times faster than your dev environment, and that's okay. You just need to know the differences. That comes down to the next point of understanding the differences between your environments. You may have solid-state drives in your laptop, whereas your server may just have traditional spinning Rust. That's okay. Just understand the differences and how your application will respond. You can use these metrics, the profiler metrics, to measure your capacity and your load, and then respond to those resource requirements. Be aware that it can change, and the more flexible you design your application, the more flexible your resource requirements can be. You can add additional servers, remove them. You can change a lot of the characteristics of your running application. If you'd like more resources, I recommend the book Practical Performance Profiling. It is a great guide to performance profiling and specifically to profiling with the ANT's Performance Profiler tool. And also you can download a free trial of that from Redgate Software. So thank you very much for attending, and now we'll take a look at questions.
Thanks, Jeremiah. Let's just give people a chance to type any questions if they have any. We haven't had any along the way, but let's keep an eye out. Do you have your email address that you could put on screen, or perhaps your Twitter name, so that if people do have any, once they finish today, they can contact you?
Absolutely. If you would like to contact me, you can contact me at jeremiah@brentozar.com. This is why you should never type live, by the way. Or you can find me on Twitter at PeschkaJ, where I will randomly tweet about all things cloud and or database related.
Okay, great. So we have our first question from Rob Sullivan, which is, with the way the cloud rewards efficiency billing-wise, how does this play into the application development's mantra of no premature optimization?
So that's a tricky question of how does it play in. And as you are moving up to the cloud, you have to keep in mind that you are being billed per unit of time, and so tuning your code and being aware of how your code performs suddenly stops being a premature optimization. And you want to at least be aware of how your code performs so you know how to scale up and scale down. Rather than running 16 web servers all the time, you may be able to turn off most of those web servers. The example of the sports team, they could have turned off most of their front-end servers apart from right around game times and right when they were running sales. So part of it is just being aware of your load in general, and part of it is being aware of the signs that your application is under stress and needs more resources.
Great, thank you. And our next question is from Jim Bears, and Jim says, what are your roadmap directions for profiling XAML in the future? XAML in the future. So I'll pass over to Elizabeth for that one.
I don't actually have very much to say on this. So obviously you'll see some things in the profiler at the moment about the applications that might be having some XAML underlying them. If you have your WPF application, then you're obviously going to be seeing what appears there. But for things that are specific to XAML, I don't think we have any functionality that is particular to that plan. But if there are things you'd like to see, we'd certainly like to hear any specific requests.
Thank you. And I think that's all of the questions for now. But like I said, feel free to contact Jeremiah or myself. I should probably include my email address on this slide somewhere. So
if you paste into chat, I'll paste it into the slide.
Oh, thank you. Technology, eh?
Yes. Science.
Okay, and it's also gone to the entire audience as well, so it's there in the chat. Brilliant.
So there you go.
Thanks very much, Jeremiah.
Yeah, thank you guys for inviting me, and thank you everyone for showing up.
Yes, thanks for listening, everyone.
Have a great day.
Bye.
Bye.